Hello students, good morning, good evening and good night. Welcome to the fourth lecture on hydrocarbons. In this lecture, we are basically discussing the hydrocarbon chapters. Different topics we have already discussed. In the lecture number 1, we have discussed about the preparation of the alkane. Lecture number 2, the properties of the alkane, and now the lecture number 3 we have discussed the preparation of the alkene, and now we are going to discuss the preparation that is not preparation, that is the properties of the alkane. Properties of the alkane that we will discuss in two different parts, because there is different types of reactions that is have been included in your syllabus. So we will discuss in two parts. It will be the part 1. In this lecture we will discuss the physical property and some of the chemical properties of the alkene. So heading of today's lecture is this is the first lecture in the properties of the alkene, that is we will call it a part 1. Actually it is a lecture number 4 on hydrocarbons. So this is K.K. Mukherjee, the Science with Mukherjee Sir YouTube channel. Properties means that we already know that it basically divides into two parts. That one is the physical property of that particular compound. Here we will be discussing the physical properties of, first we will discuss the physical properties of the alkene, then we will discuss some of the chemical properties. If we see the physical properties of the alkene, it is basically resembles, or we can say there is lots of similarity if we compare it with the alkene, except in two places. That is, number 1, its type of isomerism, and number 2, its polarity. Other physical properties, as for example, the physical state of this alkene, it basically exists in 3 different state of matters. That is, it also exists in the gaseous state, it also exists in the liquid state, also it exists in the solid state, and that is depend on the number of carbon atom that has been in the hydrocarbon. The first 3 members of this alkene is gases, and the next 14 members of the alkene is liquids, and here it exists as a solid. Second point, that is its color and its odor. It is basically found, it is exists in a colorless condition, and it is odorless. But the first member of this family, that is alkene, that is ethane, that exists as a colorless, but it has some faint, very sweet smell. Third point, that is its solubility. Naturally, it is not soluble in water, but it is soluble in organic solvents like ether, petroleum gels, etc. And boiling points of this alkene, as it is similar to the alkane, that if we increase the molecular size, its boiling point going to increases, and it is observed with the addition of the 1 CH2 group in the chain. There is an increase of 20 to 30 Kelvin of boiling point. Boiling point increase with the CH2 group. When we add 1 CH2 group, it will increase the boiling point of this alkane by 20 to 30. So these are all the physical properties. So first that is we have discussed about the physical properties. Physical properties that we have discussed, different aspects of these alkenes, that is its physical state, that is its body point, that is its color and odor. All these things we have discussed. Now the second point, that is an important point, that is a chemical properties. Chemical property, basically we will find, we know that any compound that depends on its structure. As for example, alkane we have observed it is basically inert, that is why it is called the parafins. In the same way, the alkene, it is also called olefin because it reacts with chlorine and form a oily substance it has formed. That is why it is called olefin. It is called olefin because it has formed oil-like substance when it is reacted with the chlorine. The alkene we know that is having at least one double bond, and the construction of double bond, if you understand, you most probably you know this, that is it has one sigma bond and other is pi bond. The pi bond the electron constitutes the pi bond is basically a loose electron, and this loose electron can be easily attracted by any electrophiles. That is observed, that is we have observed that in its reaction, that mainly it will undergo the electrophilic additions reactions. So if we broadly classify the reactions of the alkene, that is first that electrophilic addition reaction, and sometimes it is observed that free radical addition reaction also be conducted by this alkene. Another, that is it also undergo the oxidation reactions, it undergo the ozonolysis reactions and polymerization reactions, and it has a good reaction with the water also in presence of small amount of the sulfuric acid. That we will discuss in the next lecture. So in this lecture, first we have discussed the main important property, that is the addition reactions, and in this addition reactions variety that we will understand, different substance can be added as a electrophile in the alkene because it is having a double bond, and this one double bond, one of them bond is the pi bond, which is basically the loosely held electron. So first the reaction that we are going to discuss, that is the addition of dihydrogen. Addition of dihydrogen, because this reaction we will not going to discuss elaborately. We have already discussed during the preparation of the alkane. When dihydrogen is reacted, or we can say when dihydrogen can be added up to the alkane in presence of some catalyst, that is a nickel catalyst, platinum catalyst, palladium catalyst, at that time it is going to form the alkene. Because alkane, as for example, this is ethane. When ethane is react with this dihydrogen, it is in presence of nickel or platinum or palladium. At that time, what is going to happen? It is going to form the ethane. Ethene, that will going to form the ethene, and that will be in the presence of this. It's a very simple reactions, and from this reaction we have already discussed that it can be prepared. Alkane can be prepared. Second reaction, that is the addition of halogen. Addition of Here you can see that chlorine and bromine can be easily adapt to the alkenes, but iodine could not be adapted at a normal condition. So we will discuss the addition of chlorine and bromine, and it is going to form the vicinal halides, or we can say vis dihalides. This reaction is this. We have taken ethene plus bromine, and this bromine is dissolved in carbon tetrachloride, and it is going to form these dihalides. These dihalides, it is called in the common name of this material is called the vicinal halides, or we can say the vicinal dihalides. In this case, is IUPAC name is 1,2-dibromoethane. 1,2-dibromoethane. And this reaction is very much useful to detect the unsaturation in a hydrocarbon. And this is the situation because when bromine, when dissolved in carbon tetrachloride, it is having a its color is basically, it is the red-orange color. Red-orange color of this bromine in carbon tetrachloride solution is disappeared when it is reacted with this ethene. So is there in a unsaturation point that has been tested with this testing. That can be easily, you can able to analyze with this testing. So this testing, chemical reaction with the alkene, with the bromine is very much useful to understand the unsaturation in the hydrocarbons. In this way, you can also have this reaction, this also with chlorine, it is going to form also the dihalides, and it is this is 1,2-dichloro propane. We are taking here propene. This is a alkane and this is ethene. So we understand this addition of the halogens. Now we are going to discuss the very important reaction, that is from this reaction different type of question may come in your exam. That is the addition of hydrogen halide, or we can say HX. X may be chlorine, bromine, iodine. When this hydrogen halide, or we can say halogen acid, has been reacted with this alkene, it is going to form the alkyl halides. And in this respect, different hydrogen halide have different rate of reactions, and it has observed this HCl, HI having the highest rate of reaction at compared to HBr, and it is compared to HCl. Why it is so? Because HR here bond strength is low as compared to this bond strength of HBr and HCl. When the bond strength is low, that it can be easily broken and it is going to make the reaction much more faster. That is why rate of reaction, rate of hydrogen halides, rate of reaction of hydrogen halides is much more when it is HI, hydrogen iodide. So now we discuss these reactions, that is a very important reaction. It will form different type of products when we are adding these halogen halides in the symmetric alkenes and unsymmetric alkenes. Symmetric alkenes is those alkenes where you can find the same type of group of number of hydrogen atom is same on the both the carbon atom which is having in the double bond. And asymmetric alkene are those alkenes in which the groups are different. So when we add this hydrogen halide, it will go to form the different type of products, and that we are first we are going to discuss the addition of, suppose we are taking HBr to symmetric alkene. Symmetric alkene, we know that there is the same group on both the carbon atoms which is in double bond. As for example, this reaction, as we are taking ethene and we are taking HBr. Here you can see there is no problem of addition of hydrogen or bromine. If we put this bromine here or we will put this here, the product will be same. Product will be here, you can see H3, H2, HBr. H plus ion will add there and Br minus ion will be add there. If we add this position or that position, that will be always create a same product. So this is 1 bromo ethane. Right? This is symmetric alkane. Or you can say another symmetric alkane. Okay, that will be sufficient. I think everyone understand. Now we are going to discuss the addition of HBr. We are taking the same HBr to the unsymmetric alkene. Unsymmetric alkene. And unsymmetric alkene, what is that? Let us understand. This propene is basically a unsymmetric alkene. Why it is unsymmetric? That you can see in this carbon atom there is CH3 group, here on hydrogen, only hydrogen atom. So this is an unsymmetric carbon atom. So when we are going to add this HBr, what will be the product? Because if this Br is added here, at that time it will be 1 bromopropane, and if we add this here, it will become the 2 bromopropane. So which product will be maximum yield or major product? That we will discuss with a very, very important rule. This is called Markovnikov addition rule. And from this rule, let us first understand this rule. Two reactions. First, let us understand the two products is going to form. This is 1 CH3 CHBr CH3, and another product will CH3 CH2 CH2Br. The product 1, that is 2 bromopropane, is found to be major product as compared to the 1 bromopropane, and this has been guided by Markovnikov. What Markovnikov say, Markovnikov rules is, it's a very important rule, Markovnikov rule. is a Russian chemist. He explained this formation, why this 1-bromo-propane is produced in place of this, this is 2-bromo-propane is produced in place of 1-bromo-propane. Markovnikov said, when there is the addition of these molecules which having the one positive part and one negative part, this negative part of this addendum means that is the adding molecule will be attached to that carbon atom which is having lesser number of hydrogen atom, or we can say which is highly substituted by other groups, not hydrogen. So negative part will be joined, negative part will be attached to that carbon atom which is having the lesser number of hydrogen atom. Now we can see here, you can see this is this carbon atom, you can see here hydrogen number of hydrogen atom is less. Here this carbon atom number of hydrogen atom is high. So negative part will be joined to this carbon atom. That is why you can see 2-bromopropane is the major product as compared to the 1-bromopropane. But that we will discuss later on. In presence of peroxide, this addition of the HBr only, not HCl or HI, is found to be different. That is totally different, totally opposite. In case of peroxide, it will be different. That we will discuss with this mechanism. Now we are going to understand this Markovnikov rule in terms of mechanism of the reaction. And that will be help us to understand the Markovnikov rules. When there is a addition, that is CH3, CH, that is the propane plus HBr. HBr will produce one electrophile, that is H plus, and this is going to produce two carbocation. One carbocation is this CH3. When it is adding there, this hydrogen atom is adding there, and CH2, and this is a one carbocation, and another carbocation is this CH3, CH2, CH and CH3. Two carbocation is produced with this electrophile H plus, and Br minus is produced, Br minus, because HBr is ionized. So here you can see this is a carbocation, this is the primary carbocation, and this is a secondary carbocation. And you can understand, as due to the plus I effect of H3, this H plus ion is much discharged. H plus is ion is discharged by this plus I effect of this 2-methyl group, and that is why this secondary carbocation is much stable. This is stable and this is not so stable, right? So due to this fact, it is stable, it will produce at a faster rate, and with this we are going to found this Br minus will be add to this carbon atom, and it is going to produce this. Going to produce the 2-bromopentane is going to produce. It is a major product. Whereas this is not a major product, it is a minor product. That is 1-bromopropane is a minor product, and that is, you understand the utility or truth of this Markovnikov rule. So because that is a carbocation is produced in this process, that is electrophilic addition reaction, carbocation is produced, and this secondary carbocation is much more stable than this carbocation. Now this reaction, if we this reaction, that is addition reaction of HBr. Addition reaction of HBr when proceed in presence of peroxide. Peroxide, we are taking the benzoyl peroxide. Suppose we are taking benzoyl peroxide, C6H5CO2O2. This is benzoyl peroxide. When you are taking this benzoyl peroxide, it is going to produce the two product, that is H3CH2Br, that is 1 bromo propane, this is first number 1, and this is also going to produce this CH2. And here you can see when it is in the presence of peroxide, the addition of HBr, the product will be totally different. This will be the major product, this will be the minor product. But it is only happened in case of HBr. But if we add this HCl or HI, this product will be as per Markovnikov rules. But here the addition of HBr is in presence of this benzoyl peroxide will be different, totally opposite. And this is called the anti-Markovnikov rules. Anti-Markovnikov rules. Markovnikov rule. Or it is called Kharas effect. Kharas effects. Kharas is a scientist who has observed this effect. So why it is so? This is basically occurred. This is basically been observed due to this effect. That is, it occurred in a free radical chain mechanism. So here you can see free radical chain mechanism. Free radical chain mechanism. Radical chain mechanism. This reaction proceed. That is why you can observe this. How this is going to proceed? So you can see this is benzoyl peroxide. Benzoyl peroxide will first produce the free radical. It will produce this free radical first, and this is produce this free radical, and this free radical is going to react with the HBr and it will break the bond of the HBr. This free radical C6H5I, that is phenyl free radical, it is going to break the bond of the HBr and it is going to produce this bromine free radical, and this bromine free radical react with the same fashion as the H+. H+ is electrophile and it is a bromine free radical, and this bromine free radical will going to react with this propene. Here we have taken propene plus Br minus, and here also you can see the two types of free radical. One is primary free radical and other is secondary free radical produced. CH this is primary free radical and another is secondary free radical. This is secondary free radical and primary free radical. In the same way that we have observed here, this is much stable as compared to this free radical. So ultimately, when it is going to react with the HBr, this when going to react with the HBr, this plus HBr is going to produce, this will be going to produce this CH3, CH2, CH2Br. and this will be the major product, whereas this will be the minor product. That is why you can observe this is minor and this is major when it is carried out in the benzoyl peroxide. But why in the HCl and HI this is not going to happen? Because HCl bond strength is very high. This free radical is not going to break this bond. And in case of HI, the free radical break the bond, but there is a formation of the iodine free radical that will itself produce the iodine molecule. So that addition of the iodine in the alkene is not going to happen there. And that is why for HCl and HI you cannot see this Karos effect, but it is only for the HBr. And this is a very, very important mechanism that you must understand, because in the exam different type of question asks, you have to give in some questions regarding this, that you have been given this in peroxide. In peroxide you have given peroxide agent you have given, and you have been told that which type of product is going to produce from this, and the normal which product is going to from this. And this is very important, different type of questions asked. So that is all for today's lecture. In this lecture we have discussed very important chemical reaction, that is the addition, electrophilic addition to the alkene, and also we have discussed some physical properties. In the next lecture we will discuss the remaining reactions. Okay, thank you very much for watching.